Hello everyone! In this video, we are going to discuss one of the biggest questions in modern sports science. Can artificial intelligence replace the coach? With the rapid growth of wearables, biosensors, and machine learning systems, sport training is becoming increasingly data-driven. Today, algorithms can monitor recovery, fatigue, workload, sleep, movement patterns, and even suggest training adjustments in real time. But how far can this technology actually go? Can AI truly replace human coaching, or is the future of sport based on collaboration between technology and human expertise? If you enjoy sports science, evidence-based training, and performance technology, subscribe to the channel, leave your like, and stay until the end of the video. For decades, coaching decisions were primarily based on observation, experience, and intuition. Coaches interpreted fatigue, recovery, motivation, and readiness through direct interaction with athletes. Now, sport is entering a new era. Training is becoming increasingly data-driven. Wearables, smart sensors, GPS systems, force plates, and artificial intelligence platforms allow continuous monitoring of athletes in real time. This changes the amount of information available for decision-making. The challenge is no longer simply collecting data. The real challenge is transforming data into useful decisions. So what exactly do wearable biosensors monitor? Modern wearables can collect physiological, biomechanical, and biochemical information. This includes heart rate variability, sleep, movement, muscle activation, lactate, electrolytes, and stress-related markers. In practice, this allows coaches to monitor athletes much more continuously than ever before. But collecting information is only the first step. The real challenge is interpreting that information correctly. This is where machine learning becomes important. Machine learning algorithms are designed to identify hidden patterns within large datasets. Instead of analyzing one isolated variable, the system can combine thousands of data points simultaneously. For example, GPS data, heart rate variability, sleep quality, training load, movement metrics, recovery trends, and recent performance. From these patterns, the system can generate actionable insights. Examples include fatigue prediction, load adjustment, recovery estimation, readiness monitoring, and performance forecasting. In practical terms, AI functions as a decision support tool built on complex statistical relationships. The article introduces an interesting concept, the artificial coach. This model is based on what is called closed-loop adaptive training. First, biosensors continuously monitor the athlete. Second, algorithms analyze fatigue, recovery, and workload data. Third, the system automatically suggests training adjustments. Finally, the athlete performs the adapted session. This cycle can continue continuously in real time. In theory, this creates highly individualized training based on immediate athlete responses. But this also raises an important question. Can algorithms truly understand the human context behind the data? There are areas where artificial intelligence shows very important advantages. One of them is large-scale data processing. AI systems can analyze huge amounts of physiological and biomechanical data much faster than humans. Another advantage is continuous monitoring. Algorithms can track recovery, sleep, workload, and athlete responses 24 hours per day. AI is also extremely effective at identifying hidden mathematical patterns that may not be visible to the human eye. And these systems can provide immediate feedback and rapid training load adjustments. So AI performs extremely well when the task involves processing information and identifying patterns. But this does not necessarily mean that AI fully understands athlete reality. And this is where the limitations appear. Wearable biosensors and AI systems are not perfect. The article highlights several technical challenges. Motion artifacts can distort readings during intense movement. Calibration problems may reduce sensor accuracy. Another important issue is the difference between laboratory conditions and real-world sport environments. Devices that work very well in controlled settings may lose precision in applied sport situations. And perhaps the biggest limitation is lack of context. Algorithms mainly process numerical information, but athletes are not just collections of numbers. Emotional stress, family issues, motivation, psychological pressure, and social factors can all influence performance without appearing directly in the data. The article also discusses the so-called black box problem. Many artificial intelligence systems generate recommendations without fully explaining how they reach those conclusions. This creates several important concerns. The first is interpretability. Coaches may receive recommendations without understanding the reasoning behind them. The second issue is algorithmic bias. Many systems are trained using highly specific populations, such as elite athletes. This may create problems when applied to different populations. There are also important discussions about ethics and data privacy. Who owns the athlete's biological data? Who controls access to that information? And finally, there is the risk of excessive technological dependence. In other words, coaches may begin trusting algorithms blindly and reduce critical thinking. And this is exactly why the human coach still matters. The article makes it very clear that there are human abilities algorithms still cannot fully replicate. The first is human connection. Coaches understand emotion, fear, motivation, insecurity, and athlete personality. Another critical ability is contextual judgment. Coaches interpret external factors that sensors cannot detect. Family problems, psychological stress, social pressure, financial concerns, and emotional instability may all affect performance. Human coaches also provide motivation, communication, leadership, and trust. And perhaps most importantly, ethical responsibility remains human. At the end of the day, responsibility for athlete health, safety, and long-term development still belongs to people, not algorithms. Because of this, the most defensible future scenario is probably not AI versus the coach. The most likely model is human-AI collaboration. Artificial intelligence can improve precision, consistency, monitoring capacity, and data analysis speed. But human coaches still interpret context, communicate with athletes, and make final decisions. In practical terms, AI can expand coaching capacity, but AI does not eliminate the need for coaching. The strongest system may actually be the integration of technology and human judgment. In practical sport settings, these technologies already have important applications. They can support load management, recovery monitoring, fatigue management, injury prevention, technical feedback, and daily training personalization. Machine learning systems can help coaches identify trends and adapt workloads more dynamically. But it is important to remember something. Technology does not replace poor planning. Technology does not replace human relationships, and technology does not replace critical thinking. Technology is a tool. The quality of the decision still depends heavily on the quality of the professional interpreting the information. To finish, let's summarize the central message of the article. There are tasks where AI tends to perform extremely well. Processing massive datasets, monitoring athletes continuously, and identifying hidden mathematical patterns are clear examples. But there are also areas where humans remain essential. Interpreting biopsychosocial context, building trust, motivating athletes, communicating effectively, and making ethical long-term decisions remain fundamentally human responsibilities. So, the future of sport training probably will not be AI versus the coach. The most likely future is collaborative. Artificial intelligence functioning as decision support, while coaches remain responsible for contextual interpretation, ethical responsibility, and athlete-centered care. If this video was useful, subscribe to the channel, leave your like, turn on notifications, and share this video with coaches, students, and sports science professionals. Thank you for watching, and I'll see you in the next video.